This is a 3D printed RC wheel loader, and it has the ability to swap between this bucket and a variety of other attachments thanks to this quick coupling plate, which not only automatically connects, but also sends power to those attachments, like this street sweeper with a powered brush. If you need to move something large, you can drop the sweeper and hook up to this grapple, which is great for picking up and transporting rundown equipment or really anything. Then, if you need just a little more reach, swap to the crane attachment, which has its own linear actuator. Whether you just want to move sand around, unload your RC log truck, or clean somebody's shoe, this wheel loader has an attachment that can do it. Or if you need something completely new, there's this base template to create your very own custom attachment. I had a ton of fun designing this project from the ground up, but it was definitely a bit of a rocky start. Alright, I've gone ahead and sketched the rough outline of a wheel loader. Emphasis on rough. For whatever reason, the ratio of front to back was really hard for me to figure out. I believe it's because the overall footprint changes so much when the arm is moved up and down, but it quite literally took me days to get the sketch to just this point. I've never used blueprints to figure out the dimensions of real life equipment. Everything is always free-handed from the ground up, which certainly has its downsides, as more often than not, excavators, wheel loaders, and forklifts are designed the way they are for a reason. I'm not above using reference photos though. For example, I really like the way this Volvo L350H looks, and I think this sketch portrays that. To get a three-dimensional model, I split it into all the different pieces that make up a wheel loader: rear body, front body, cab, wheels, axles, etc. From there, I can place all those super simple shapes into an assembly and start figuring out how everything is going to fit together, as well as how it needs to be designed so that when it prints, it's as strong as it can possibly be. The first part / subassembly I really dived into were the axles. Now, some feedback I got on the Dozer was that you guys really loved these much larger motors due to the fact that they're more powerful as well as practically indestructible compared to these small N20 motors. Because of this, I've decided to do my best to incorporate them into this project as well. There is one massive downside though, and it's that they are quite literally massive, especially when compared to those N20 motors. Because of this, the main size determining factor of this project will be how small of a form factor I'm able to fit these into alongside a drive shaft and drive shaft housing. It's then a question of how I'll fit that into the front chassis that's already going to be crowded with 3 linear actuators to move the arm. Printing out my first drive shaft pieces, you can see there's a little bit of support required, but I just want to say that I never get tired of looking at a good old tree-generated support structure. To hold the axle in place, I'm using a 37mm bearing on each side, which can be tapped in using a mallet or your preferred mass moving tool. With the axle in hand, I started hollowing out a spot to fit it into the front and rear bodies, which did require some serious math. I did get the front and rear chassis to a point where I could mount the axles, which involved this dovetailed style connection that slides together and is then fully secured with one screw. One of the many things that makes wheel loaders so cool and unique is the central pivot system. When this thing wants to turn, it doesn't just angle its front wheels. Nah, that'd be too easy. Instead, this thing literally pivots its entire 100,000 pounds of mass in order to turn. Other than just flexing on the rest of us who achieve turning by the use of 2 wheels, I guess there are some valid reasons on why it's the way it is, such as a stronger front end axle connection, ideal for moving heavy loads, can turn around in about half the space as a conventional vehicle, and the rear tires always follow the same tracks as the front tires. Now, a real wheel loader pivots using hydraulics, but for my model, I've decided to take a much simpler route and use this 20kg servo. This should be super overkill for what we need, as I've used these in the past and they have a ton of power. Thanks to the accuracy of a servo, it'll be much easier to get everything centered. You can pick up one of these servos for about $13, and I feel like that's a really good deal. To get it fitted, I imported a rough outline into my 3D model and made some space in the rear chassis. I then created a pinion gear for the servo, as well as a receiving gear on the front body. I'll be using some 15mm bearings on this central pivot point to maximize smoothness and strength. While this all seemed very copacetic, when I went to mount that servo in the real world, Well, turns out I never thought through how I was actually going to get that servo into its mounted position. Moving on, I laid out the design for the arm pretty much just by slapping in some pivot points, making sure parts weren't going to run into other parts, and yeah, I'm sure not thinking it through more now isn't going to haunt me for weeks down the road. The arm pieces print flat, and because of this, there's a fair amount of support material required, which is a bit more of a theme on this build than previous ones, as I'm leaning in the direction of more whole pieces rather than a bunch of sub-assemblies that need to be screwed together. The arm gets mounted to the front body via 2 screws, and putting the first linear actuator into place, I think it's a good time to talk about this new style of linear motion I'm trying versus the old version, which were N20 motors with threaded rods installed. For the excavator, dozer, and crane, I utilized these by 3D printing a hollow push rod, inserting an M4 nut, and then running that nut in and out using the threaded motor. These work pretty well and they're very cost effective, but they have 2 major downsides. The first is the quality of the motors varies a ton. I've had batches that provide a ton of pushing power and are just overall fantastic, but I've also had batches that could hardly move a damp paper towel. And I know others who have experienced this as well. The second downside is there's no built-in limit switch, meaning when you hand the controller over to a 5-year-old or someone who doesn't know the machine's limits, well, they're gonna ram right up against the end stop and try going past it. This is fine the first couple times, but over time this does take its toll on the motor. A solution would be to add physical limit switches, but I'm personally against this as that would mean a ton of extra wiring. Enter these encased linear actuators with built-in limit switches. These absolutely rock. They're super efficient thanks to the lead screw, which is sealed in with grease. The built-in limit switches mean once it reaches the end of its threaded rod, it just turns off rather than ramming into it. I've found that you can get pretty good deals if you order 3 of them, which is exactly how many I'll be using on this project. But deciding to use these is really only half the battle. Getting them to fit in the front end of this model is its own ordeal. As you can see here, I totally missed the mark for how wide this mount needed to be. So I ended up cutting one side of it completely off and just sticking a screw through it for the time being. The lower actuator, which is responsible for lifting the entire arm, slotted in no problem. And I just ran some power through it using a spare battery I had laying around. It had a surprising amount of power given the fact I'm only using 1/3 of the recommended 12 volts. The actuator going to the bell crank seemed to work well, but I won't really know until I officially hook it up to the bucket. Printing off another front and rear body, I opted not to use my expensive gold colored filament this time, but rather my cheapest prototyping filament, as I'm sure there will be many flaws with this version as well. I pulled the bearings from the previous design and removed all the support material on the new design. The 2 halves combined were actually able to pivot more than 10 degrees, though there's still more room to grow. The servo pinion gear is first mounted to a circular servo horn, then the servo. That then meshes in with the front end, which is also where I realized that because the pivot point is directly underneath the servo pivot point, that whole gear extravaganza does absolutely nothing. I could have just mounted the front piece directly to the servo and had the servo pivot the front end, which is exactly what I changed the design to do. Popping the bucket off the printer did make me feel a little better about that oversight, because now this thing is starting to become less of a thing and more of a wheel loader. The cab I tried printing out as one solid piece and then sliding the black inner frame in, which proved to be a huge pain. Ultimately, I think I'll separate the top and have it sandwich the black inner piece. The rear hatch design was one I spent a lot of time working on for both functional and aesthetic reasons. My goal is to place all the electronics, which includes the wiring, circuit board, batteries, in the rear, and then stack them in layers. The rear hatch will pivot at the bottom, giving easy access to anything you need. This will also just click into place as shown here. Up to this point, this model has basically just been an immobile log with no ability to move due to not having wheels. So this will be my first stab at tires. And I tried to go with a realistic looking tire with curved edges and a hollowed out core. The hope being it would be flexible. Well, it wasn't. Even with 95A TPU, which is a little bit flexible, but mainly extremely durable. And it also just looked pretty lame. So I scrapped that and made these cool lugged off-road tires, which I do plan on resin printing a silicone set for this model, which if you've never seen that before, you are not going to want to miss it. The circuit board snapped into the frame nicely, and there's still plenty of room for the batteries. I also started soldering on the motor wires and routing everything to the rear hatch. To get this project moving under its own power, I first need to actually solder all the components to the PCB, which connects all the critical components that make this model functional, such as the ESP32, which acts as the brain, this 5-volt buck converter that takes the 12 volts coming from the batteries and makes it usable for the servos, the H-bridges, which act as the middleman for the motors, handling the large amounts of power required, but leaning on the ESP32 to tell them how much and which direction to send that power in. If I were to funnel power directly through the ESP32 to the motors, it would fry that ESP32. This PCB is ultimately just a tidy way to send power and signals between all the components and eliminates what would otherwise be a rat's nest of wires. For the batteries, I 3D printed this flat holder and popped on some contacts, which I then wired in series so that when all 3 batteries are in, you'll have 12 volts. This then just hooks into the PCB, which has its built-in on-off switch. Unfortunately, after soldering everything onto my PCB, it no longer fit into the holder as I didn't take into account the fuse holder getting in the way. The battery holder though, that snapped in nicely. At this point, I've gone through every piece 2 to 3 times, and everything is working. Maybe not optimally yet, but it's functional. Because of this, I hit the full send button by printing everything in this Hatchbox Gold PLA and assembling the first complete model. Though before I can take this shiny new whip for its first test drive, I've only covered 2 sides of what I'm going to be calling the triangle of creation, which is mechanical design, aka the 3D printed parts, the electrical design, aka circuit board, batteries, wiring, etc., and the final third side, code, aka magic. The code, which will be loaded onto the ESP32, will parse all of the controls coming from a PlayStation controller to functions on the wheel loader. To do this, I'm going to use a library called BluePad32 by Ricardo Quesada. You're able to download and use this library directly in the Arduino IDE. Now, lucky for me, I don't have to write all this code from the ground up, as I can use the code from the Dozer or Semi as a starting point, then just alter all the commands and functions from there to match up with the wheel loader. Starting out, I decided to place the boom motion on the left bumper and trigger, bucket tilt on the right bumper and trigger, throttle on left joystick, steering on right joystick. Once the code is uploaded, it's as simple as turning the model on and then holding down the share button followed by the PlayStation button, which puts the controller into pairing mode, indicated by the flashing blue, and will connect to the truck a few seconds later. And yes, you are able to drive multiple of these at the same time, as they'll all pair individually. Controlling the center pivot servo for the first time did prove to have more than enough power for this application, so much so you can do this comical wiggle. Deploying it on the table for the first time was sweet, but a rather short-lived experience, as I immediately unmasked a ton of bugs. Such as that if the bucket is overextended, it gets stuck and needs to be pushed back up by hand. I also wasn't able to place the bucket flat with the ground, which made scooping beans difficult. There was also just many other small isms that needed to be addressed. Fixing the bucket was easy enough, as I just made it sit slightly lower, as well as carved out some of the front body to allow the lift motors to settle lower. I added a hard stop on the arm itself to prevent the bucket from overextending and getting stuck. Placing it back on the table, I was finally able to get my first taste on how cool this is really going to be. And I'll go ahead and just shut my trap for a moment so that you might also appreciate it. Previously, while I was modifying the arm, I noticed the bucket had a ton of free play, and while that's impossible to mitigate completely, a lot of it was coming from this central bell crank pivot, as it's experiencing the most torque out of any part when the bucket is tilting back something heavy. So instead of having this pivot on a screw where it easily gets worn out, I inserted a shaft with the bearing pressed on and then pressed that into the bell crank. This eliminated most of the free play felt in the bucket. Now, while this is working and is cool, I'm gonna be honest, the arm is still far from acceptable, but I'm also slightly burnt out on redesigning the arm so many times. So I'm gonna take a break from that and move on to something that's had me so excited since the start of this project, which is the idea of a quick coupling attachment plate that will allow the user to swap between different attachments. Then to really push the envelope on what's possible, I would also like that attachment plate to have a power and ground connection, which would allow there to be DC motors on the attachment itself. I started by just drafting a quick mock-up, the key part of mine being this servo, which will run the pins in and out. For the power and ground connection, I hollowed out the inside of each pin so that a wire can be run through it and locked in place with a grub screw. The end of the wire will be stripped and spread out over the end of the pin. The first prints came out great and the servo slotted into place no problem. Assembling the pin linkage also went smoothly. A problem arose though when I started trying to move it in and out. The issue is, at first the angle from the servo arm to the pins is really steep and it just wants to push each pin out to the side rather than into its slot. If I provide a bit of pressure on each side to simulate a wall being there, it then slots in no problem, which is exactly what I added, and it worked great. Hooking this into the bucket was super satisfying, as it feels like it's just going to work. And if I sound a little crazy saying that, I blame all of the headache I've gone through on the arm design. It just feels great to have something that works and works well right off the bat. Wasting zero time, I pulled the old arm and bucket assembly off the wheel loader, admired the fake hydraulics, ran a servo extension cable through the front and into the rear, rehooked up the linear actuators, made sure I didn't mess up any of the core functions, then proceeded to connect the servo, which made me realize the original pass-through I made for the wires was not nearly big enough. Never mind that though, as I pushed a new version of the code onto the ESP32 so that I could control the attachment servo using the up and down buttons on the left D-pad. And now it's time for the big question. Does a week worth of work actually work? It does, and it works really, really well, meaning the next thing to do is design a whole line of attachments for it, starting with a crane attachment. This was a nice, easy one to do, as the idea is to just slot in a linear actuator to the supported base, lock it in via one screw, run the wires out the back down to the attachment point, and finally add a hook onto the end of the actuator. This one attachment was definitely needed, as currently the only heavy high lifter I have is this mobile crane, which is awesome and by far the most complex model I've ever made. The problem though is it's the most complex model I've ever made, and it's really, really challenging to build. So I don't expect many people to have this in their fleet. This wheel loader and crane attachment setup is infinitely easier to print and build as well as to use. The next attachment I decided to tackle was a bucket and claw combo. This one proved to be a little tricky, as at first my gearing was just way off and the claw was opening and closing at the speed of sound. Then, after gearing it down a whole bunch, it still didn't work, as when I went to clamp down on something, even though it had a lot of clamping force, as soon as I released power to the motor, the gears would backdrive from the stored up energy in the slightly flexed plastics, causing it to lose its grip on the object. All the claw designs I've done in the past have used a servo. Servos hold their position, meaning you can squeeze down as much as you need and the servo will stay there. Unfortunately though, a servo just isn't an option in this instance, so instead I changed course and designed a worm gear driven system, which is famous for being non-back drivable. It's also an extremely compact way to achieve a high gear reduction. It did take me a couple tries to get it right, but once I did, it allowed for a claw that was way more usable. Adding to the attachment list, I decided to tack on a street sweeper. This was a relatively quick and easy one to do, as I already had this brush design from the skid steer. Thank you, Brandon. I just imported it into my model and got to work resizing it to fit. The first variation ended up having too thick of bristles, so I went back through and shaved them down. 3D printing these are really cool, as instead of relying on traditional support, you place these towers around the brush, which the very end of the bristles can stick to. Later, you go through and either cut or pop those towers off. Now, the final attachment I decided to make in this first initial wave was a log loader or grapple setup. This was definitely the most requested attachment I got, as it can be super versatile and is great for moving almost anything around. To save myself some headache, I reused the worm gear mechanism from the bucket setup, but made the entire assembly narrower by pulling in the sides. The claw portion was also a spin-off of the bucket claw, just narrowed down and reduced to 2 thick support arms. Now, before I go and test out these attachments, I'm going to take another stab at the arm, starting with some new motors. I've ordered a ton of these 12-volt actuators in order to see what the best speed option is, which can be referenced right here where this one says 15 millimeters per second. This is the speed I have been using, and I found that they're a little too fast for my liking, and I'd be more than happy to trade that speed for more lifting power. So next, I'll be trying this 7 millimeter per second one on the bucket, which is half the speed. And well, it's actually a little too slow now. But also, I really need to thicken up this bell crank, as after I added that bearing, it's now a little too thin around the edges, as the newfound power just busted right through it. There's so many small changes that have been added into the digital model but haven't actually been printed that I've decided to create a whole nother wheel loader. For this version, I opted for a bronze black color scheme, and everything you see laid out on the table here is what will go into the finished model. Also, while I'm building this, I'll be keeping track of anything that needs to be revised for better fitment, better printability, or just a beta cosmetic change. For example, all of these bullets were created just from removing the support material. Assembly hasn't even begun yet. One big upgrade to this rendition is the addition of leaf springs to the rear axle. This should help keep all the wheels in contact with the ground, making it more capable. Powering up the new build for the first time, I again had the realization that the arm just still wasn't good enough. The attachment was running into the arm, causing it to back drive, and the range of motion at the upper end just wasn't enough. On a happier note though, the rear leaf springs proved to be so functional that I've decided to add them to the front as well, which did mean spending the good part of a day modifying the front body to make room for a couple mounting holes, but the rest of the day was spent in a steely-eyed stare down with the arm. I meticulously went over every pivot point and every lever arm length one last time, checking every range of motion at every angle, as well as making sure the point at which the bucket tilts up is at the appropriate point in the bell crank fulcrum so that there's actually usable power. After a couple hours, the only thing left to do was send it to the printers and hope all of those changes translated to the real world. The result is, well, an arm that actually has the range of motion needed to be functional. At the top of the range, you're able to tilt the forks back to either hold something in the air or tilt it all the way forward to say dump beans out. At the bottom end, you have enough tilting power so as to rock a truck back into position to carry it, but most importantly, the cloth stays perfectly level when lifted and lowered through its range of motion, all thanks to how the different actuator and arm mounting points interact with each other. Moving on to demonstrations, I'm first going to show the street sweeper, as I've got a little bit of a bean mess going on. I mounted 2 motors on this attachment to give it the most oomph I could, and well, this might just be the most humorous attachment, as it's just a little ridiculous, and I always get asked if the brush is 3D printed as well. To which I say yes, and offer them a quick shoe cleaning service. I will make it a little wider so it covers more area, but overall, it's a really fun addition. Unhooking from the brush, I moved into the traditional bucket, with no powered pieces. Now this is of course for moving material, and for that I'm gonna need mo beans. One of the big reasons I wanted to do this build was to have something capable of filling up the side dump on the RC semi-truck. You are able to do it with the excavator, but even with the oversized bucket attachment, it takes a long time. So to try this out, I threw some batteries in the semi, hooked it up to the side dump, and plopped down next to the wheel loader. As to be expected, this wheel loader is able to far outpace the excavator, or really anything that came before. Not to diss on the excavator though. That thing is sweet, and can construct a tower out of almost anything, as well as scale mountains like a goat. But the wheel loader, with just 3 scoops, you could easily say this little truck is ready for transport, though I did add 2 more for good measure. Next, I'm going to be using the crane attachment, which just from trying to connect with it, I'll definitely need to widen out the base, as it's a little too front heavy and tips over easily. Once hooked on though, it makes for a pretty cool fishing experience, and I was able to fish this RC skid steer out from the depths using it. From there, I just hauled it over to the ledge of shame. Now the final attachment in the demo will be the grapple. This thing can move whatever you need it to, such as this trailer. Stepping it up a notch is the semi-truck with the batteries loaded. Now this weighs a significant amount more than the trailer, and while it had no problem lifting the truck, it took a little too much weight off the rear axles. Now luckily, the wheel loader has a ton of spare room in the rear hatch, meaning you can add these wheel weights inside of it, which is what I did, and with them, I was able to maneuver the truck around, albeit somewhat haphazardly, and place it on the trailer. Steering is definitely a little impeded when it's this front heavy, but I plan on adding even more weights to the rear, which should balance it out. I also tested this out on the log truck to see how it would do unloading and loading logs, kind of like this thing that you'd find at a real mill. The first time I just tried a half load, and the second time I went with a full load. The wheel loader with this grapple is definitely my favorite, as it's just so fun to play around with. especially on the floor of a living room. Seriously, it's the perfect weight to pick up a shoe and run away with it, or a pillow, or a book. The possibilities are endless. With all that though, there's still more work that needs to be done. First being the powered attachment functions. Currently I have it set up so triangle and X only power the motor when pressed, then square and circle turn the motor on until that button is pressed again, at which point it will then turn off. What I found is that people would accidentally press square or circle with an attachment like this grapple, and it would run away on them, crushing down on whatever it was holding or letting go of it. Same thing for the quick coupling pins. Occasionally the disconnect button would get pressed and the attachment in use would just fall right off. To fix this, I altered the code so that in order to activate the continuous on motor function, you have to tap the square or circle button 3 times in quick succession. For example, to turn the brush motor on to sweep forward, I tap circle 3 times in a row, which activates it. I repeated the same safety feature for the quick coupler as well. To disconnect, tap down 3 times. Another bit of feedback I got was that while some people really liked the snappy steering that matches the position of the joystick, others wanted it to increase like I mentioned before. Though I didn't want to just have one or the other steering option available, so I've made it 2 separate modes that can be toggled between by pressing the left joystick like a button. When first powered on, it's set to snappy quick steering, but when toggled via the joystick, it switches to the incremental steering, which is great for small, precise movements. Finally, I addressed the lights. Previously, they just had the ability to turn on and off, but like with the Semi, I set it up so that you can cycle between on, blinker mode, and hazard mode just by pressing the right joystick like a button. This is just how I personally like the controls. I know some people may want steering and throttle to both be on the left stick, which in that case, all of this code is easily modified, especially with the help of something like ChatGPT, where you can copy and paste my script into it and ask it to move some of the controls around for you. Then just upload that new altered code version to the wheel loader to get your desired control layout. I refreshed the Gold Loader with all the new updated parts and also decided to make a set of true silicone tires, which involves this Formlabs printer. Now this stuff is super gooey and nasty, so full PPE is highly recommended. To de-goo the pieces after printing, it's a bit of a process, which starts with putting it in a container of isopropyl alcohol and then putting that in an ultrasonic bath, which in essence uses sound to create tiny air bubbles that break off any excess material. The final step is to place it in a beaker of water and add some Febreze spray, as this stuff doesn't smell great. That then gets placed in this cure chamber and blasted with UV light. The final result is a super grippy, squishy silicone tire, which gave me enough grip to conquer this mountain, at least on the second try. While this is a really cool process, it's definitely not for the everyday user. The traditional TPU tires are infinitely easier to make and work more than good enough for most scenarios. In fact, that's what I ended up putting back on the wheel loader for a beach day. So if you'd like to build your own RC wheel loader, consider checking out the workshop on my website, professorboots.com. The workshop has step-by-step guides on all of these projects and covers everything you might need to know, such as sourcing parts, how to get the PCBs made, code, assembly, etc. On top of that, I also release an update video every week talking about what I worked on, what issues I'm running into, or if I make a fun additional attachment, I'll usually share it on there. The workshop is what funds the development of all of these projects, so a huge thank you to everyone who supported this build. Alright, so with the wheel loader now added to the fleet, it's time to choose the next project. So please leave a comment down below on what you'd like built next. It could be a crawler crane, road grader, an updated skid steer, you name it. Whatever has the most votes will be the next project. Thank you all so much for watching, and I'll see you here soon with another project.